Hello judges, myself Rohan from Team Cepstrums from Rajalakshmi Engineering College, team ID 357. The problem statement that we decided to solve is AI-based acoustic wave monitoring for rail defects like cracks, fractures and prediction of rail wear and tear. And the solution that we propose for this problem statement is RailGuard AI. A AI-powered railway track failure detection system. So without any further delay, let me give you a brief overview of our solution. Usage of a transmitter. A transmitter has been used in order to propagate the LAM waves. The LAM waves propagate through the railway track, and then if it detects any crack or a fracture, it sends it to the receiver. And for the receiver part, we have decided to go with using a piezoelectric diaphragm which is attached to the railway track with the aid of adhesives. And this piezoelectric diaphragm is further connected to a edge device. The signals from the piezoelectric diaphragm is being sent to the edge device for processing. And once the signal processing is being done, the device tells us whether there is a crack in the railway track or not. Now, why use an edge device? An edge device has been preferred in order to process the data on the receiver's end. Further, implementing CNN model on the edge device in order to process the raw data that has been received from the piezoelectric diaphragms. And also, the noise present in the signal is being identified and cancelled out with the aid of DSP. And finally, the CNN model will be able to predict whether there is a crack or a fracture in the track by analyzing the received signals. The communication. In order to mitigate poor connectivity and also in order to maintain a separate connection, LoRa is being preferred over here. And along the receiver's end, the LoRa module is connected to the edge device. Thus, with the aid of multiple LoRa modules, a LoRa mesh network is being formed, thus allowing the messages, the real-time data from the LoRa module to the database. And now for the database, we use SQLite. Now in the database, various parameters of the track are being updated. And also, if a crack or a fracture is being detected, a warning message is being sent for the purpose of inspection. And also, the status of the track is being updated in the database. And now, for the final part, the synthetic dataset. In order to train the CNN model, we have used the synthetic dataset that we have collected. And apart from that, we have also used Abacus in order to simulate the UIC60 railway track with its same and original properties. With the aid of the simulation, we were able to obtain how the LAM waves were able to propagate through the UIC60 railway track. And we were also able to obtain a sample dataset. And this particular sample dataset is being trained under a GAN model. With the aid of the GAN model, we were able to synthesize more amount of datasets. And for the conclusion part, the dataset that we obtained mimicked the properties and it matched with the original synthetic dataset. Thus, we further used it in order to train our CNN model. Thank you.